So welcome to our next panel. We're going to discuss, can cement or concrete become carbon negative? And joining me on the panel, I have Sada Sahu of Solidia Technologies, Apoorv Sinha of CUT, Carbon Upcycling, Rio Okumura of Mitsubishi Corporation, and Ryan Cialdella of Ozinga. So welcome, gentlemen. And Sada, we'll start with you. Perhaps if you could give a short introduction of yourself, and then the technology, Solidia in your case, and then we'll go through everybody, and then we'll get on to the discussions. And for all of the people in the audience, if you'd like to ask questions, then please go to the Q&A tab and type in the questions. And it's better to do that early because there seems to be a bit of a delay in us seeing the questions. So please type the questions as soon as you think of them. Sada, over to you.
Hello, everybody. My name is Sada Sahu. I'm a principal scientist at Solidia Technologies. And at Solidia, we are developing new cements, and mineral carbonation is one of the main topic we are dealing. And also we are developing new SCMs, and I'm responsible for developing the cement and SCM. And okay, so what Solidia Technology and how we do things. So in cement industry, we know there are three main sources of CO2. One is from the raw material calcination, the other is from the fuel, the third is from electricity, and a small amount from transportation. The main three sources are out of these three, at Solidia, we are dealing with the first two, the decarbonation of limestone and the fuel. So how we do it at Solidia, the Solidia cement is, the raw mix is designed with a 30% lower in limestone content. So the main phases of hydraulic phases are not present in the Solidia cement. The main phase is wollastonite. And how the Solidia cement gains strength is during carbonation, wollastonite carbonates to produce calcium carbonate, primarily calcite, and silica gel. And that's the binder phase. And the second opportunity where we reduce CO2 is this clinker is clinkerized at 1250 degrees C. So it's almost 200 to 250 degrees C lower than OPC. And in that process, we can save from 20 to 30% from fuel CO2 emissions. So the overall CO2 emission in this process is somewhere 50 to 60%. And in certain applications, we can go higher, depending on the level of carbonation. And at Solidia, we have taken this technology for different applications like pavers, particularly we have introduced in the market, and Solidia pavers, and they are very well accepted in the marketplace. Our customers are willing to pay a premium for Solidia pavers. So that's a positive drive for Solidia to introduce in the market. On top of that,
could I just clarify there? So what you're talking about there is precast unreinforced products. Is that correct?
That's correct.
Yes. Okay.
But having said that, it's not limited to unreinforced concrete. We have developed technologies where we can really use it in reinforced concrete too. But that's further down the road. But initially, we are introduced with non-reinforced concrete or precast. But okay. This technology is limited to precast. In situ curing is not possible. So it has to be managed and cured in a controlled environment. So we expand this technology to developing a new type of SCM, basically take the Solidia cement and carbonate to produce calcium carbonate and the silica. That's the silica, which is amorphous, is a pozzolanic material by itself. And the calcium carbonate produced from this carbonation process is forming some monocarbonate in the system. So it's kind of a pozzolanic material. I can call it a smart pozzolanic material because it has some performance of slag and some performance of limestone reacting with the residual C3A, and also the silica combining with lime. So it's kind of a hybrid smart pozzolanic material.
Okay, so thank you, Sada. That's a great introduction. So may I move on to Apoorv from Carbon Upcycling Technologies. Apoorv, if you could give us a brief introduction along the same lines.
Absolutely. Thank you, everyone. Thanks, Ian, for the opportunity to be a part of this. Let me know if you're able to see my screen here.
Yes, we can see that.
Okay, great. So I'll just quickly go through a short introduction on what carbon upcycling does. We're a Calgary-based startup company that started about 7 years ago. And as Saad mentioned in one of his works at Solidia, we're also focusing on the upcycling of supplementary cementitious materials. Generally speaking, what we've found with our catalytic milling process that we've developed over the last 6 years is that we're able to chemically activate a range of different pozzolans. These could be mine tailings, natural pozzolans that are mined from open pit mining, or a range of industrial wastes, such as but not limited to fly ash or blast furnace slag. And we can activate them to capture CO2 while also significantly improving surface area and reactivity, all in a single step unit operation that you see in the middle of the screen here. The main value propositions that we've been able to establish, apart from the direct sequestration of CO2, are the fact that we're able to take a versatile range of feedstocks. Folks like Ryan from Ozinga and others have been able to kind of investigate the use of our technology with various feedstocks. And we're very excited about the type of engagement and interest that the industry has shown in exploring those angles. And also the fact that we've actually been able to scale up our work quite aggressively. Like just in the last 3 years, we've scaled up the demonstration that we've done by over 1 million times. The value proposition overall is what we've been calling Concrete 2.0. Essentially, the angle here is that we've demonstrated now in the field with ready-mix concrete that we're able to reduce the clinker or cement content in the concrete mix by at least 10%, in some cases over 15%, and in some lab trials well over 20%. This allows for not only a much lower carbon footprint on a per cubic meter basis, but we've also seen that it significantly improves the durability aspects of the concrete. Essentially, we've seen chloride permeability numbers drop by as much as 50 to 70%. We've seen sulfate expansion and alkali silica reaction numbers significantly mitigated as well. And we've shown with our scale-up work in Canada so far that not only is this possible to do at scale, but can actually be relatively cost-effective and very cost competitive as people look for effective ways of decarbonizing. This has been validated to a certain extent by some of the partnerships we've developed with folks like Wholesome, CMEX, and CRH. And as I mentioned, there's a broader coalition of folks in the ready-mix space that we've been engaging with as well. The pilot demonstration that we've got going this season here in Canada is the unit that you see behind my colleague here, Natalie, on the right-hand side of the screen. We're actually co-located at a natural gas power plant here. So we've been able to take CO2 directly from point source emission, run it through an amine capture system, and feed it into our reactor that you see behind my colleague. This unit has now run over 100 runs over the course of this season. And we've delivered over 10,000 cubic meters of concrete through Burnco and primarily Wholesome in the Western Canadian market thus far. What's exciting about this is both of them have been able to demonstrate that double-digit cement reductions are possible. And of course, none of that would be remotely possible to achieve in the field if we hadn't also shown that we were compliant with the relevant ASTM and CSA regulations as we've been able to demonstrate. I'll just finish by saying that overall, we're very excited by how quickly we've been able to get into the field. As we know, the construction sector tends to be conservative and needs a lot of validation before things can actually be deployed on the ground. But we believe we've developed an excellent launchpad wherein this type of technology could be customized for local feedstocks in different regions of the world and allow for significant cement reductions or at least clinker reductions in cement, depending on where this may be deployed, be it at a cement plant or a ready-mix plant. So thank you again, and I look forward to participating in this discussion.
Okay, thanks, Apoorv. Rio, if we could move to you, I guess some people may be surprised that Mitsubishi Corporation are involved in this discussion. So perhaps you can explain how Mitsubishi got involved in this and what you're doing.
Yeah, I agree with you. Probably most of you don't know what Mitsubishi is doing right now. Actually, I'm not selling automotive. I'm not selling air conditioning machines. So I'm doing the investment work based in Houston. So let me quickly introduce myself and what Mitsubishi is doing. Are you on the same page? Yeah.
Yes, we can see.
Okay. Yeah. This is me. Yeah. Actually, I'm in Houston, and my background is energy, and very important thing, I'm a tech guy. I'm an investor. I'm not tech guy. So if you have any questions, please ask Sad or Apoorv. That's better. And actually, what Mitsubishi is doing is we are doing so many things across 10 business groups. We are involved in oil and gas, mining, mining and petroleum, and upstream to downstream, and retail business as well. So, but all in all, our greatest challenge is decarbonization. Very recently, when Mitsubishi announced net zero towards 2050, which is very challenging because most of our business is coming from fossil fuel, to be honest. So as Mitsubishi Corporation, we are very keen to enhance our capability to support and grow decarbonization business by leveraging our existing business portfolio. And actually, most of you don't know that, but Mitsubishi Corporation has business assets in construction materials as well. I will explain later on. This is our current portfolio in terms of our corporate venturing works. I'm leading Mitsubishi's decarbonization corporate venturing based in Silicon Valley industries. Now I'm in Houston, and I'm still leading this corporate venturing works in CCU type of technology. I think that some of this technology are very famous. We'll highlight CO2 silicon. This is Japanese technology, similar to Solidia. But actually, Japanese government is very keen to support CO2 silicon to enhance its technology to be utilized in ready-mix industry as well. And one more thing. Actually, if you wish to have a net negative concrete, probably you have to address in aggregates as well. I mean, lightweight aggregate by sequestering CO2 into limestone. That probably important component for in the context of net negative concrete. This is my last slide. And as Mitsubishi Corporation that has existing business assets, and we are really keen to harness new technology in early adopter market, which is California. In Southern California, LA, and Mitsubishi Corporation and Mitsubishi Materials, our sister company, has assets, cement assets, and also ready-mix assets named Robertson. Robertson has largest share in South California and San Diego, Las Vegas, such as attractive city, and they are very keen. The government are very keen to harness this type of technology. And LA City is hosting Olympic Games in 2028. As you can easily imagine, every Olympic Games highlights construction, of course. And we are really keen to showcase next generation concrete industry by leveraging our business asset in South California, and we are very keen to communicate with government as well. And so once we could demonstrate this kind of technology or entire decarbonized concrete industry, we are very keen to go to market in Asia, Europe, any other region as a project developer in this world.
And before you move off that that slide there, is your plan for the 2028 Olympics to offer carbon negative or zero carbon concrete?
Oh, actually, we are very keen to do that. And by leveraging our portfolio companies, yes, we will offer to produce net negative or carbon neutral concrete for the construction works. Yes.
All right. Thank you. So, Ryan, if we could come to you and your excellent view of Chicago behind you.
All right, thanks for letting me be a part of this. And my name is Ryan Cialdella. I oversee our innovation and market development here at Ozinga Ready Mix. We're a Midwest concrete supplier and also in the South Florida region. We operate about 80 ready mix plants and close to 800 trucks. But you know, we have had this big focus here in the last three to 4 years on really how do we start to look at reducing the clinker and the CO2 emissions for every yard of a concrete that goes out the door. You know, I guess we're kind of where the rubber meets the road for a lot of the different technologies my fellow panelists work on. We kind of collaborate with them and validate from a commercialization standpoint, how do we put all these different pieces together? Because I think as everyone would agree, there's not one single way just to make your concrete net zero or negative. So you've really got to take a look at all these different ideas, strategies, admixtures, technologies, and just see what can we put together and synthesize and make it work together without really affecting the performance, right? Because that's also a big concern for this, as we know from our firsthand contractor base, is that we could provide very low carbon concrete, but if it messes the schedule up or changes the way that they build, that's going to be an issue. So we've had a lot of conversations and continue to really push that envelope forward with them, as well as the specification community. Architects and engineers are now coming to us looking for solutions because they realize that concrete isn't going anywhere. I think we can all agree that that's a good thing. So, you know, how do we help them achieve these goals, such as, you know, Rio said of the SE 2050? It's a real thing. And for us to get there, we need to all work together, from the owners of these buildings all the way down through the third tier subs. So, you know, I think it's a great topic, you know, and it's going to take time and effort, you know, from everybody all across this industry to really get as close as we can to zero.
Okay, thank you. I wondered if you've seen something that I was talking to a contractor that's working on HS2, which is a high-speed rail project in the UK, and they've been trying to use the clays that they are excavating in the course of the cutting and the tunneling as a cementitious material, you know, something along an LC3 type of a product. Actually, this clay is not very good quality. It's probably the average kaolinite content is 15–20%, so about half or perhaps less than half what you really need. But they said actually they were looking for ways to use that in, you know, lower quality concretes for paving or for fill or that sort of thing. Have you seen the same thing in any projects that you're involved in? That the asset owner or the contractor is saying, well, you know, this is more important than meeting the standards?
I wouldn't say I've seen it locally here. We obviously have looked at LC3 and different calcine clay options. You know, and for us, you know, as a supplier, it's a big logistical issue as well. So wherever they're located or wherever the kiln is can dictate whether it makes sense. It may be lower CO2, but if I have to transport it halfway across the states, it kind of negates the advantage there. So we haven't necessarily seen that as much as we have seen, you know, looking at utilizing recycled aggregates, you know, crushed concrete, things of that nature. That would be, I would say, a little bit more prevalent to our local market, at least.
Right. Okay. We have a question that's come in, and this is for Apoorv. Is the footprint reduction in concrete coming from mineralized carbon dioxide or cement content reduction, or both?
it's coming from both, but not equally. As I'm sure someone like Ryan would know about this best. I think with all the different technologies he's looked at, and potentially Rio, you're on a crash course on learning this as well. But ultimately, I think the majority of reductions do come from cement displacement for pretty much all carbon tech companies. I think apart from potentially Blue Planet, because they're carbonating the aggregate, which tends to be a much larger proportion of the concrete mix. In our case, the ratio that we're seeing in terms of the CO2 reductions that come from cement displacement versus direct sequestration is about 4 to 1.
Okay, thank you. So if you, maybe I can ask a question, Rio, to you and perhaps also to Ryan. What is the limiting factor today? I mean, why are we not seeing more low carbon or zero carbon concrete used?
In my opinion, actually, the CO2 sounds available, but no, it's not available. CO2 is very, very expensive, very costly product in the market. So first thing we have to think about is logistics of CO2. Yeah, actually, to capture CO2 is very costly, and also to transport CO2 is also costly. So as Apoorv presented, and collocated with natural gas power plant or any other fossil fuel related asset is very important. But usually ready-mix plant or cement plant is located in different places. So we need entire value chain thinking to think about logistics of CO2.
Yeah, I think this is a theme that goes through discussions that we have. So for example, this morning we were talking to a panel on CCS, and this was again a theme that went through that panel. One of the panelists worked for Calix, and they have this a LELAC process, which is trying to take the CO2 essentially from a sort of preheating of the limestone, so that you get a very pure CO2 off there, maybe 95%. So, not a food grade, but a relatively pure CO2. So again, that's a very interesting possibility to combine that kind of process, perhaps capturing 10 or 20% of the cement plant CO2 with, for example, your process, Apoorv, or one of the other processes that also uses CO2 in the chemical, in the production of the alternative products.
Otherwise, direct air capture. Yeah, actually, we Mitsubishi is very keen to have direct air capture technology in our portfolio.
Do you see that as being something that can be cost competitive? I understood that the power consumption was something like 2,000 kilowatt hours per ton, which seems pretty eye-watering in terms of the costs as well.
I agree with you. But actually, not only for this building material industry, but also CCS industry is now very keen to harness direct air capture technology. Actually, we do have experiments. We do see the experience cost benefits by leveraging other business such as CCS. Right. So now governments are very keen to harness that direct air capture technology. So let's see. I'm very optimistic, to be honest.
Okay. Ryan, from your perspective, sorry, Apoorv, you want to say something? Go on.
Sorry, Ian. Yeah, I was just going to say one thing about the cost of capture. I think Rio made a very good point about, not all CO2 point source emissions are the same. And I think one of the things we have found is that from a technological perspective, the more kind of companies can show that they can take dilute streams of CO2 instead of needing pure CO2, the more I think it can accelerate the transition of some of these technologies into the field. I mean, to Rio's point, a big advantage for us was the fact that we were co-located at a natural gas power plant where the government had already done an investment in an amine capture unit. But the feedback that we received over the last 6 to 9 months, and I'm sure, Saad can talk to this as well from a Solidia standpoint, we found that we had to do some flue gas testing, and we've done some of that now and seen some really promising results. And the thinking is that if we can make it such that the capture piece can be maybe segregated from the utilization piece perhaps, and with direct air capture, to your point about the high energy consumption, it's that high if you're trying to get to high purity. If you only need to get from 400 ppm to 4 or 5 or 10%, and that's okay to go into a process like ours, the cost can come down quite dramatically. So I think it's finding that sweet spot, and that really is a technical challenge more than perhaps an industry challenge. But there are definitely both as we look at this.
Yeah. So Ryan, maybe I come to you in just a second. I was just going to ask Sad the same question in terms of sourcing of CO2. I think when I talked to Solidia a little while ago, you were using basically high quality CO2. Is that still the case, or have you been able to find other sources?
Yeah, it's the case. Currently, we are using, say, food grade CO2, but we have plans how we can directly use from the point source. But point source is also, it comes, say, different concentration of CO2. You go to a coal-based power plant, it's hardly maybe 10% or 12% at the most. But if you go to an ammonia plant, you may get a higher concentration. So, or a cement plant may be higher concentration. But now the challenge is how the impurities in the flue gas is going to impact your process. That's critical thing you need to look into. And I want to point out another part of the equation is what is the limitation of the CO2 sourcing is one part. But once you make a mineralized product, once you are going to use it in concrete, there are the codes and standards are not up to date to accommodate you, whatever mineralized product you make. So the balance need to be, the codes and standard need to be updated, and we need to be more progressive to accommodate these products so that these things can flow. So that the equilibrium need to be maintained in a way. Absolutely.
Ryan, can I come back to you? In terms of what you see as being the barriers and why we aren't seeing a greater take-up, what's your take on that?
I think there's a couple things at play here from my perspective, and things that we run into is one, as Sada just mentioned, standards. Not every DOT, not every specification has anything outside of the standard, C-150s, the 989 slags, the 618 fly ashes, right? We got to start looking at the 595 blended cements, the 1157 hydraulic cements, blended supplementary cementitious materials. I think that's one big piece to it, because that's where a lot of this innovation is going to come. But if I, from a ready mix supplier standpoint, if I can't use it on a majority of my products, it's hard for me to invest in the assets and capital needed to put in additional silos just to have it there for these couple of jobs that I can, right? So that's one. Two, I would say is accounting, right? We need to know exactly where we're at, right? And that's where the environmental product declarations come in, because if you look at the NRMCA, nationwide EPDs, they're fairly conservative in nature, just because of the data set that they're using, right? But we really need to hone in on, our exact materials, and then take it a step further and say, okay, these are our exact materials, but now I need product specific EPDs for those, right? So for one instance, we saw one of our suppliers went and got their own product specific EPD, and it dropped our cement impact by 20%. So, now that's not going to be every case, but to know exactly where we're at, you need to know to try to get to zero. So that's another piece. And then third, I think, is just industry. Our industry is slow to change. The contractors, the fear of the unknown. When you say low carbon concrete, everybody assumes that it's going to take longer to set. It's never going to get strength, and they're going to have huge construction delays. So it's again, and I hate to beat this drum, but collaborating from the beginning on these projects early on the applications that we can really push the boundaries and get to as close to zero as we can. And Rio was right. You get to some point, then you got to start adding on new things, whether it's carbonized aggregate, so it's a multifaceted approach that we're trying to tackle each one at the same time, yet it can be a challenge just to get everybody understanding and rowing in the same direction.
So I have a question here from Raman Mangabai, who asks, who is responsible for specifying the low carbon cement and concrete for structures? So maybe, Ryan, that is pretty much to your point there.
Yeah, I think it's driven in multiple facets, right? It's either the owner, the end owner of the building says, these are our goals. This is what our company stands for. So this is how I want the building built. We've also run across other progressive structural engineers and architects that are pushing the boundaries. You know, and even general contractors and developers. We've got one that we work with that has set limits for different strength classes that say this is the direction we're going, and you can't give me a 4,000 psi concrete that's above this GWP number. So we're kind of seeing it coming from all angles, to be honest, at this point.
Right. Okay. Is it all of these code and standards issues? This is more important than cost, is it, in terms of moving forward on low carbon solutions?
It's a tricky question. I think at some point there's going to be this crossover where cost isn't as important right now. You know, from our perspective, what we've seen, it's a lot of data collection. Everybody wants to, you know, what's your GWP, where you at, how you working to make it better. And that's kind of where they're at, right? They're trying to figure out what their baselines are, right? We establish our baselines for the concrete, they establish their baselines for buildings. And at some point, when you start to get closer to these deadlines and people need to go out to the open market and buy carbon credits, the price of the credits is a dollar amount, right, to get them to zero. So maybe at that point, the cost of the concrete, because obviously the time and energy and effort that, you know, everybody here on this panel puts in, there's value to that to help them get there. So at some point, a little more expensive concrete may be more of a benefit than just going out and buying carbon credits. So you know, we're not there yet. But I think at some point, you know, cost isn't going to be as much of a driver as it still currently is.
Okay. Could I just, sorry.
I echo importance, Ryan's point, importance of accounting or counting of carbon and also the carbon credit. I'm originally from energy industry. So energy industry is very keen to have the benefits from carbon reduction, or probably the cement industry is the same. They wish to have some benefits from carbon reduction. But actually, usually ready-mix industry is not super keen on carbon reduction. So not like energy industry, not like cement industry. So I think how to connect this difference in the interest in carbon credit or carbon reduction, it needs to be connected via carbon accounting or carbon credit type of business. So that's very important thing.
So thank you for that, Rio, because we have a presentation at the end of the day on this very topic of carbon credits and what's happening there. And I think what you're talking about there is very important.
I want to make one more point on that. I think the movement, say in US, like vaccine mandate, right? So local governments mandate that their employees need to be vaccinated. So I think the CO2 reduction, I think it need to start in a local level, the movement, so that say a community says on my structure need to have that much carbon footprint or that movement. I think if we change that concept and the movement starts from local level, I think the acceptance of material will be more and more.
So on that point, Sada, are your products, the Solidia products, are they going to B2C customers or are they going into big projects?
It's various projects. It's not necessarily big projects, but the small projects, residential projects also. But we have a lot of commercial projects. Yeah. And
is it the asset owner that is saying, I want, you know, Solidia, or I want low carbon products?
It's a combination of things. Sometimes owner asks for it. Sometimes the people, our partners, so they convince people, hey, this is a new product and you need to look into it, low CO2 footprint. And say a small homeowner, he's educated on CO2 concept. And he said, oh no, I want to, instead of regular paver, I want to put this paver.
Mm-hmm. Okay. Rio, can I come back to you on a slightly different point? You were mentioning earlier the need for this sort of cross-industry collaboration. And I wonder if we're going to see in the future more industrial hubs where the carbon capture or the carbon usage is either centralized or there's some people generating carbon and some people using carbon in the same hub. I mean, is that something that Mitsubishi, I guess some of that could use oil and gas infrastructure, maybe it fits in nicely with your portfolio. What's your sort of global view on that?
Definitely. Yes. So oil and gas industry is now crazily keen on CCS opportunity to protect their existing business. Meaning in North America, in coming 10 years, the huge CO2 infrastructure will be laid down across soil of United States probably and Canada as well. And so anyway, we have to sequester or store CO2 underground. This is no doubt. But actually, in the case of concrete, yeah, you have the opportunity to utilize CO2 with cost-effective way. So we need to think about the holistic value chain. Probably right now you have to purchase CO2 right now. So without having this type of demonstration capability, probably the cost of next generation concrete won't be decreased. So it's a tough time right now. But end of the day, the CO2 infrastructure will be laid down very soon. And not only energy industry, oil and gas industry, probably renewable energy is very important. Yes, as you pointed out, if you think about direct capture, you need power, you need energy. And if you utilize the coal-based power for direct capture, that's crazy idea. Yeah. So yeah, we Mitsubishi Corporation is very keen on renewable energy as well. We acquire a large power company in Europe, and they are very keen on renewable energy, the wind, solar. So I think probably we have to think about oil and gas industry and renewable energy and other CO2 industry. So this holistic view is very, very paramount success factor.
Okay, thank you for that. Could I throw a question at Sada and Apoorv? In both cases, your companies have been around for several years. What do you think is the biggest challenge, if you like, or the biggest hurdle in scaling up the business? Sada, maybe I'll come to you first.
Yeah. So this technology, say in case of Solidia, for example, we had several years we have to spend to really scale up the concept of making this cement or clinker in an existing cement plant. So now, you have say in a cement OPC raw mix design and the liquid phase and how the clinker happens. We have to simulate those things, and it took several years to get to that point. Now, the next phase is the application part or mineralization part. And now that's a big challenge because it has to be in a controlled environment. This carbonation has to take place. And depending on the application or the product you have, the carbonation time may take longer or shorter depending on the product size or element size. So scaling up to a full-scale product like a bridge beam or a double T or something like that, it will take a long time. So the scaling is the understanding the mechanism, how this works, and scaling up to an industrial scale takes time. And this is a big challenge. The scaling up for different products. Okay,
thank you. Apoorv, what do you see as being the biggest challenges, the biggest barriers?
Yeah, I think Ryan kind of hit the nail on the head. Like, he introduced himself by saying he's the group with whom the rubber hits the road, and I think he's exactly right. And I think there's I'd say there's a couple of challenges. So one would be, how do we make sure that that pricing challenge for any new technology to be most competitive from a pricing standpoint on its first plant is not very likely. Like in fact, it's probably a recipe for failure if you're going to argue that. And so being able to do that and still be able to get into the market to kind of give them options, I think is a key thing. And progressive folks like Ozinga, I think are ways to make that happen. But it still takes time. I mean, it takes, a whole bunch of work to get that level of confidence built. I mean, each concrete break takes 28 days, right? So, I mean, you might take a week and a half, 2 weeks to get the samples over, and then there's still this massive lag that you have to account for. I think the second piece is really the urgency from the entire system. I know Saad mentioned kind of local policy. I'm actually thinking, I'm more the advocate of kind of the higher end top-down approach where, you look at the federal government in Canada, they've said any federally procured project in 2030 will need to have 40% lower carbon emissions than the baseline that they've set. I think that a signal like that goes a long way towards telling everyone that, yes, we need to have a solution now and start working towards that goal. And yeah, I mean, like you said, we have been around a few years. We really only started looking at cement and concrete about 3 years ago in 2018 when we were participating in the Wholesome Accelerator. And we've seen a massive change in momentum since the beginning of this year, to be honest. Like, I think things were kind of edging along before, but there's been a rise in intensity that we're pretty excited about. And the hope is that, we can leverage that towards a couple of commercial plants in the next year or so and quickly scale from there.
Okay, well, thank you for that. It looks to me as if we have reached the end of our time. So thank you to all of you. It's been great to talk to you about this topic. I'm sure we could sit down over a beer and continue all night long. But so thank you to Ryan, Rio, Sahu, and Apoorv, and thank everybody for watching.
Thank you.
Thank you.
Thank you very much. Thank you for having me. Thank you.